am on page 26 in Unit 1, Lesson 2, and this is screencast number 3. I'm looking at the blue heading, How do scientists use logical reasoning? Scientific explanations are evaluated using logical reasoning. Logic is a system of thinking used to determine whether a statement is true. Logic can also be used to predict what else may be true and what else may be false. Logical reasoning uses logic to draw conclusions based on valid evidence. Scientists collect empirical evidence and analyze it to develop a scientific explanation that best fits all the evidence. Scientists must determine whether evidence comes from a reliable source, meaning a source that can be trusted. A scientist knowledgeable in a particular field of study is considered a reliable source. However, an advertiser trying to sell a product is often an unreliable source. Scientists must also check for bias in an explanation. Bias favors one result over another. Remember, we touched on bias in the last lesson. It's sort of like if you're biased, you sort of kind of make up your mind before you hear everything. Okay? So it's very important that you understand that certain people are reliable sources for scientific knowledge and certain other people are not. A scientist who's an expert in a particular field would be considered a reliable source, but an advertiser trying to sell you something would not be considered a reliable source. And somebody who may not be an advertiser and they may not be an expert scientist in that field either. They're neither, but they're not a reliable source either. Okay? Okay, on page 27, I'm going to allow you to kind of do that yourself. You do not need to do number 17, but I do want you to answer number 15 and number 16. Okay? Okay, here's what my page 26 looks like now that I've gone back and highlighted a couple of things. I highlighted the sentence that says logic is a system of thinking. Logical reasoning uses logic. I highlighted that sentence. Scientists collect empirical evidence, blah, blah. That sentence. And of course, I put an extra arrow because I want you to really, really, really understand that someone who is an expert in a scientific field is considered a reliable source, while other people are not. All right, I'm now on page 28. Why is it important to examine all sides of scientific evidence? Scientists may not always agree on the best or most logical explanation for existing evidence. And when scientists disagree, they continue to conduct investigations and collect evidence in order to further support or revise current explanations, or to arrive at a new scientific explanation. In science, the term proof means that a theory is supported by evidence. Scientists rarely consider a scientific explanation to be proven because scientists always consider the possibility that new evidence may someday cause an explanation to be revised. Scientists use phrases like the results support and the results fail to support to describe a scientific explanation. So they're real leery about saying this proves, something, okay? Because it's always possible for things to have to be modified in light of new evidence. Okay. We're going to kind of go through number 18 together. Look at example number 1, and in the blue it says the impact of a large meteorite caused the extinction of the dinosaurs. So this is a scientific explanation that they are giving us, and then they give us A, B, and C, and they're asking, does it support or does it fail to support the scientific explanation? A. Iridium, a substance found in meteorites, was found in clay formed 65 million years ago at various places on Earth. Okay, that tends to support the explanation that we're looking at. A mass extinction of dinosaurs and other organisms occurred 65 million years ago. Again, that tends to support the explanation that we have up there that says the impact of a large meteorite caused the extinction of the dinosaurs. C. Evidence of major volcanic eruptions in India occurred at the end of the dinosaur age. That one's a little iffier. The scientist, that's probably going to be a fails to support, because scientists, as you discovered in your reading, sort of decided that that was not the reason why the dinosaurs became extinct. It may have been one of the many factors after a meteor impact, but it by itself was not going to cause that. Example number 2, the scientific explanation that they give you. Life existed on Mars. Okay? This is an explanation, and we're going to look at A, B, and C and see if those things support or fail to support those explanations. Organic molecules containing carbon, like those on Earth, have been found deep within a Mars meteorite. Okay? If that's in fact the case, then that would tend to support the assertion that life existed on Mars. It's not saying that it did, it's just, it would be one thing that would tend to support that assertion. Would obviously, we would need those kinds of molecules if life did indeed exist on Mars. Okay? So finding them in a meteorite would lend support to that explanation. B, Mars may have had an underground water system between 3.6 and 4 billion years ago, because water is another essential ingredient for life, as we understand it. That would tend to support the explanation that we're giving also. C, meteorites discovered on Earth have been identified as coming from the surface of Mars. The fact that the meteorites came from Mars doesn't, that's not a particular piece that's going to support our assertion that life existed on Mars. Okay? If, the meteorites may not do anything to help prove that life existed or did not exist on Mars. Okay? And then example number 3 is down at the bottom. The scientific explanation that they're giving: eating a raw diet means food that is not cooked. Eating a raw diet supports a healthier body. Okay. Many foods require cooking to release key nutrients. That would tend to work against our scientific explanation, so I would check fails to support. B, in general, raw food eaters eat fewer calories and are less likely to be overweight. If that is something that we can, if that is an explanation that we can support with evidence, then that would tend to be an explanation that supports our scientific explanation that we've got up there. C, eating a raw diet is easier than eating a normal diet because the food does not need to be cooked. Okay, they're saying it's easier versus not so easy, but that doesn't support our explanation that eating a raw diet is healthier. Okay? So those are just some examples of things that we kind of have to use logical reasoning to critique pieces of a scientific explanation. Once again, on page 28 and 29, you can now see sort of what I did, where I highlighted, and the fact that I boxed each scientific explanation for each example and checked either supported explanation or failed to support explanation. Okay, I'm now on page 30. No, I'm not going to do this for you, but this is just another reminder that this is part of your lesson assignment, that you are to do all of the active reading questions. Notice that this one says 19, 20, 21, 22, 23, which means that back in the reading that there were 18 other ones that you should have gone back and answered. You also need to do the lesson review questions as part of your grade. And there are a few vocabulary terms that you probably need to make sure that you know as well. Okay. Okay. I modified my list just a tad, so you might have seen some sort of jerk and then all of a sudden there's this new list. It's not really new, but just make sure you have these words and you know what they mean. Method, theory, experiment, field work, logic, bias, logical reasoning, and empirical evidence. Those are all words that we saw in this lesson. All right, thanks for joining me.